Alright guys, aren't we special? Figured I'd go over one more problem for you, just for the heck of it. Just to give you a little more practice, you know. It's a good one. It's a special problem. I'm real excited to go over it with you. Alright, so, unattached earlobes is a dominant trait. In a population, 67% of people have unattached earlobes. Calculate the frequency of people who are homozygous for attached earlobes. Alright. Looks like I put car lobes there. Sorry guys, it does say ear, I promise. Yeah, that just made it worse. But anyway, okay, so this problem is really tricky, and this is a nice little loophole I could throw you guys. So, we know that unattached earlobes is a dominant trait, okay? And 67% of people have attached earlobes. Okay, so we want to find how many people are homozygous for attached earlobes, or the frequency, you know, percentage. So what are we trying to find here? Well, let's go back to our equations. If they are homozygous, that's what we're trying to find, it's either going to be p squared or q squared what we're trying to find. One of those two. So how do we determine which one is it? Well, they're homozygous for attached earlobes, and attached earlobes is dominant, so we know that big R is what we're trying to find. Alright, that's our overall goal. So let's try to figure out something here. So 67% of people have unattached earlobes. We know big R, they're going to have unattached earlobes. Little r, no, they wouldn't be, you know, unattached. So what do we do here? Alright, I got an idea. Check this out. So we know that this one here is going to be attached, right? So we know that's attached. We know this is unattached. Big R, little r. This is where the loophole comes in, or the trick, I guess you could say. Big R, little r is also going to be unattached, right? So both of these together is our unattached phenotypes. Alright? So let's use that. We know that the unattached is 67%, right? So 67%, or if we put it as a decimal, we would just divide that by 100, so we get 0.67. Alright? Can we solve for something here? Yeah, we can, because now we know that these two together are 0.67, and we can add q squared to that to get 1. Do you guys see what I did? I just completed the rest of the equation there. So I know these two is 0.67 together, and now I just do plus q squared equals 1. Alright? So if we solve for q squared, you should get q squared equals 0.33. And then just like we did in the past, we can take the square root of each of those. And the square root of 0.333 is about 0.57. So we know q is 0.57. Alright, so now we have our q. We got a fresh piece of paper here. We know that q is 0.57. Now let's go to the other equation to figure out what p is. We know p plus q equals 1. P plus 0.57 equals 1. Subtract 0.57 from each side. And P equals 0.43. Okay? And that's pretty much the end of our problem, guys. All we got to do now is we know that this one right here, that's what we're trying to find. That's our end goal. All right, that was my failed attempt at an exclamation mark, but there you go. Do the best I can. What do you want from me, right? But we know that our big R, that's our p squared. That is our overall homozygous for attached earlobes. So let's go back. All we got to do is square our p. We know that p is 0.43. We just have to square that number. and I got 0.1849, okay? So if we're calculating the frequency, we do not have to put it as a percentage, and that's our final answer. If we want to round it, we could say just 0.18, okay? And that's our frequency for those that are homozygous dominant or homozygous for attached earlobes, right? Hopefully this problem is a little bit more challenging. You guys can see that only difference between this one and other ones we've done is, you know, it gives us a percentage for both of our characters that are showing the dominant phenotype. So, all right guys, have a good rest of your day.